Hello, we're going to take a look at your MT2 LT8 affirmation right now before you complete a redo. On the first graphing one, I think you're a little confused there about what that means. If you're confused about graphing, always go back to making a table. Make an XY table. Notice X is always 8 because X equals 8. There is no Y. So Y could be anything in the world, but X has to be 8. So if I go like -1, 0, and 1. So I go over 8, go down 1. Go over 8, 0, 8, 1. In fact, I could do that forever. You get a vertical line. That's what you should have graphed. What you graphed, this line would be y equals x plus 1. Or not 1, 8. Because your y-intercept is 8 and your slope is 1. When you have an equation that only has an x or only has a y, if it's x equals some number, that's going to be a vertical line. If it's y equals some number, that's going to be a horizontal line. If it's y equals mx plus b, that will be your diagonal line, which is what you graphed. So you got a little confused there. Let's take a look at another one. And once again, I think you got a little confused. You graphed slope-intercept form. This equation says write it in point-slope form. And by the way, even if you did slope-intercept form, that would be incorrect because the y-intercept happens when x is 0. And you don't have x being 0 here. So off of your seminar or your formula sheet, your formula is y minus y sub 1 equals m parentheses x minus x sub 1. Now, you just plug your numbers in. Y and x are your variables. X sub 1 is -9. Y sub 1 is 5. So we should have said y minus 5 equals your slope, which is 4/3, which I think you knew that too, times x minus a -9. Now you can simplify this a tad. Instead of writing a minus a -9, you can just write +9. But if you start distributing, then you're going to start putting it back in slope-intercept form, and we don't want slope-intercept form for this problem. I just want the answer. This was one problem you probably didn't need to show any work. You just had to write the equation in. Let's take a look at the third one. Now, this third one definitely want to see some work. To find the slope between 2 points. Slope is easy and fun. It's rise over run. You subtract the y's over subtracting the x's. So if we look at line 1 here, this is what I mean. I need to see some work on this one. Label your points. Whoops, get out of there. X. Whoa, that's way too thick. Let's try to make that a lot thinner. I don't know what I did there. Okay, so you got x and y and x and y. That's what we're going to do. So we're going to say -4 minus 4. So we say -4 minus 4 all over your x coordinates. Let me make so you can see it. Let's shrink it in here. 6 minus 0. Well, -4 minus 4 is -8. Notice you had that one correct. Over 6 minus 0, which is 6. Then you want to reduce that. That's -4 over 3 because we can divide the numerator and the denominator by 2. I'm wondering what you did to get 7 on this. This is why I need to see your work. So -4 over 3. By the way, your other two slopes are correct, but you want to reduce those. So 9 over 12, I could divide each by 3, and you get +3 over 4. Make this a tad bit bigger so we can write it. And when divide both by 2 on line 3, you get +3 over 4. Now that you got those correct, now let's take a look at what's going on here. Between line 1 and line 2, your slope is -4 over 3 and 3 over 4. They're negative reciprocals, so they are indeed perpendicular. Not the way you did it, but they are indeed perpendicular now that we corrected it. Between 1 and 3, they are also perpendicular. And finally, between 2 and 3, notice they're the same. If you reduce that, then you would have seen, because I see why you did neither, because they weren't the same. But if you reduce them, they are the same, so they're parallel. So at this point, I want you to go back and redo this affirmation. Send me your work. Excuse me. Had a little something in my throat there. Send me your work when you're done. Show some work. Take a picture of it. Don't just put in a bunch of answers, because you end up with the same score and you're going to be frustrated.